All right, so we have some homework questions related to the conversions between grams, moles, and things. Things like atoms, molecules, formula units, fundamental elementary identities. So we'll do 3 or 4 questions from the active homework here. All right, first one is determine the quantity of nitrogen atoms in 15.0 grams of lead to nitrite. Okay. So they give us grams and they're asking for atoms. Okay, so we'll start with this. That's what they gave us. And somehow we need to get to this. Okay. In order to go to atoms, you have to go through moles first. So we're going to go grams to moles to atoms. Okay. So without doing any math yet, ugh. All right, and then we need to calculate the molar mass. So this is how I would set up my molar mass calculation. 1 lead, 2 of the nitrites. I know that's not the correct Lewis structure, but for this problem, it doesn't matter. So we got 2 nitrogens and then 1, 2, 3, 4 oxygens. So that's how I would do those subtotals. I think I did that in my head right. We'll check. All right, yes, we did. So let's get a subtotal. A total. $299.21. Okay, and then we just look for the option that has a 299.21 or something close to it. Yeah, that'll work. Okay. Now this is where I've seen a lot of people get into trouble, like in my office hours. People will start using Avogadro's number too early or too late or in the wrong spot. The mole always gets a 1 next to it. Okay. And when you're going to fundamental units, the things like molecules or formula units, that's where you use Avogadro's number. Okay. They did give a distractor here of 10 to the 22nd, 6.04. That's just wrong. So, I hate it when that happens. But 6.022 times 10 to the 23. Molecules, PbNO2, it should say formula units, but whatever, because it's an ionic compound. Now, if they wanted formula units of lead nitrite, we'd be done, but they want nitrogen atoms, okay? So we need to realize, we need to think about how many nitrogen atoms are in the formula unit, okay? One of these gives us 2 nitrogen atoms. So we have 2 nitrogen atoms per molecule, all right? I guess I was a hypocrite and did my units last, but whatever. Okay. And then we have to do like the answer. Zoom out. And then you put your answer. Okay. Okay, next problem. Determine the quantity of moles in blah, blah, blah formula units of sodium chloride. Okay, mole always gets a 1. And if you're dealing with fundamental things like molecules, formula units, atoms, that's always going to get Avogadro's number. And then that's it. Okay, next one. Oh, this is looks like a similar problem as to the first one, except it wants oxygen atoms instead. I should have put those two back to back. Whoops. Oh wait, units first. I can't be a hypocrite. Okay. No, I was on autopilot. I need to eat dinner, man. Let me see. Molecules. Needed mole. There we go. There we go. Okay, grams to moles with a formula with a molar mass, and then Avogadro's number to molecules, and then they're asking for oxygen atoms. So we have 4 oxygen atoms in a formula unit of the lead to nitrite. So we'll have a ratio. One molecule gives us 4 atoms of O. Okay, and then your answer will have whatever it is, and the units would be atoms of O. Okay, next problem. All right, ascorbic acid. How many molecules of ascorbic acid with 1025 milligrams of ascorbic acid? Okay, so we have to go grams to moles to molecules. Except they gave us milligrams, which is kind of annoying, so we have a little busy work to do there. Okay, let me get a new piece of paper. Okay, so normally it's grams to moles to molecules. And here we use the molar mass, and here we use Avogadro's number. Okay, but we have an additional busy work step of having to do a milligram to gram conversion. Okay, all right, so let's put that in the app. And we're going to need 3 factors: milligrams to grams, grams to moles, and then moles to molecules. how much is C6H8O6? Oh, I have that one memorized. It's 176. Okay. Oh, I have to do units first. In active, you can grab the grams and the moles separately, or you can grab the molar mass units of grams per mole. If I were to put it here, it'd be grams over moles, but if I put in the bottom, it's going to put the grams at the bottom, and then the moles will go at the top, because a denominator in the denominator is mathematically equivalent to going to the numerator, the top. And there you go. All right, 176. And when you're counting out individual things, you want Avogadro's number. Okay. Oh, there it is. Answer. There we go. Yeah, and then multiply it out. Okay. I didn't show the math on the first few. I'll give a complete example for one of these. So let's see. 1025 times 1 times 1 times 6.022 times 10 to the 23 divide, open a parentheses, 1000 times 176.12 times 1, close parentheses, 3.50. Let's check on sig figs. We're going to have 4 sig figs because, yeah, the initial number is 4 sig figs, and most problems it's sig figs in is sig figs out. That's a conversion factor. That's exact. This conversion factor involves a measurement of molar mass, so that's 5 sig figs there. What I meant to say for this conversion factor is it's a metric system conversion factor, so it's exact. So sig figs don't count, and here we have 4 sig figs, so we're going to go with 4. So that's going to be 3.505, and I need 10 to the 21st power. And it's happy. All right. Let me know if you have any questions. Have a good day. Take care. Where's the stop? Here you are.